Hi, so I've got another worked example for you. This is another question using the suvat formulae for horizontal motion. Okay, so I'm going to read out the question. A train moves along a straight track, so horizontal motion, of course, with constant acceleration. 3 telegraph poles are set at equal intervals. Besides the track at points A, B and C, where AB is 50 metres and BC also 50 metres. Doesn't matter, they're the same distance. It's easily done whether they're different or the same. The front of the train passes A with speed 22.5 metres per second, and 2 seconds later it passes B, find the acceleration of the train. Okay, so most of our information, it seems, is related to A and B, isn't it? So what we're going to do is we're going to do it from A to B. If you want to use vector notation, you can do from A through to B. So from A to B, well, it passes A with a speed of 22.5. So I've got that. U is 22.5 metres per second. 2 seconds later it passes B, so I've got the time. T equals 2 seconds. I need another bit of information. I've got S, distance between A and B is 50 metres. Let me just write that in there. So S equals 50 metres. Find the acceleration of the train. Okay. So the formula I'm going to use there is S equals ut plus half at squared. Okay. So the idea is that you pick out the appropriate suvat formulae, not that one, this is from a previous video, it's going to be this one, that involves the letters I've just written down, so S, U, T, A, okay, and here we go, I've got S, U, T, and I need to work out an acceleration, right, so here we go, let's use S equals ut plus half at squared, here's our solution, so S, which is 50, equals 2 times 22.5, sorry, ut, okay, that times that, plus half at squared, and you can solve for A, work out what A is. I assume you can substitute numbers in yourself, I'm just more going through the method than actual calculation for these ones, hope you don't mind. But B, the speed of the train when it passes C, so this time what I'm going to consider is move from A through to C, okay? So you've got a choice, you can do A to B, B to C, or A through to C. In a particular scenario of this question, I'm going to go for A through to C. The reason for that is because you're given the speed when it passes through A is 22.5. So you can still use this here. U is 22.5 if you consider it from A through to C. Okay? And the total distance is 50 plus another 50, that's 100. So S is equal to 100 metres. I've worked out the acceleration actually, and assume my answer is correct, which it is, I'm going to use that again. A equals 2.5 meters per second squared. I need to work out what V is. So the speed V when it passes through C. So for this one, I'm going to use that there. V squared equals U squared plus 2AS. Okay? And if you see in the working, that's exactly what's been done here. I'll just show you. So V squared equals U squared, 22.5 squared, plus 2 times A times S. 2.5 multiplied by 100. And then you can work out what that is, and V turns out to be 31.7, down to 1 decimal place, meters per second. Lastly, the time that elapses from the instant the front of the train passes B to the instant it passes C. Well, what I'm going to do is I'm going to do the same sort of thing again actually, okay? Because I've got a lot of information now about what's happening from A to C. So I'm going to use all that information that I have to work out the total time taken. Okay? Now, I know that after the time taken from B to C, but because we're told the time taken to get from A to B, 2 seconds, I can just work out the time taken from A to C and subtract 2. Makes sense? So they're moving from A through B to C, and because I know from A to B is 2 seconds, from B to C must be the difference between 2 and whatever the time is from the whole thing, from A through to C. Okay? So I can use any bit of information now. So I've got U still is 22.5, S is 100 metres, A acceleration is 2.5. I know the velocity V when it passes through C. So I've got lots of different options that I can use. Consequently, you'll see that there's more than one way of actually doing it. You can use V equals U plus AT, so V is that, U, as we know, 22.5, A, so we can use that if you wish. Or you can use S equals UT plus half AT squared. So S we know, U again we know, half AT squared. whichever one you use, you'll end up with the same value of t there, 3.69. But don't forget that's from A through to C. To get from B to C, you've got to subtract the initial 2 seconds, okay? So subtract 2, you get 1.69 as your final answer. Okay, hoping that made a lot of sense to you. Thank you very much for watching. I'll see you again.